Math 3, Unit 9, Section 5 notes. Please make sure you complete the logarithms activity before you start the Section 5 notes so that you understand what's happening here. But the laws are listed at the top in case you forget. So, we are going to expand all of the expressions on this page, which means we are going to, our answer is going to look a lot more complicated than what we started with. So, starting with the first one, I have log base 7 of 7x. Now, 7x means 7 times x. So, when you go up to look at your log laws, then you'll notice that the first one is the multiplication one, m times n. So what this means is if you're multiplying two values together, then you can separate those values by rewriting it with multiple logs of the same base. So my base is 7. I'm going to rewrite this as log base 7 of 7 and log base 7 of x, and I need to know what operation goes between them if 7 times x is our multiplication. To expand, it changes to addition. Okay? If I were to be doing 7 divided by x, it would change to subtraction. If I were to be doing 7 to the x power, then it would change to be multiplied the exponent out to the front. But since it's just 7 times x, we change from multiplication to addition. Now, please make sure you check your expression that you're writing down. If you can simplify it more, you must simplify it more. Now, log base 7 of x, that means 7 to what power gives you x? I have no idea because I don't know what x is. But 7 to what power gives you 7 can be solved. 7 to the first power is 7. So we can simplify log base 7 of 7 more to give you 1. Because 7 to the first power is 7. All right. Next one, natural log. We have an exponent and multiplication in this one. So we're going to do separation of the multiplication first because it's because it's 6 times x cubed. So we want to do 6 and x cubed separately. So this would be natural log of 6 plus natural log of x cubed. But we're not done. We want to expand completely. So if we can expand more, we will expand more. Natural log of 6 is going to stay the same. But this last law, when you have an exponent, you can multiply it out to the front. So this 3 can be multiplied out to the front to give you 3 natural log of x. So that 3 is being multiplied out to the front. So 3 ln x. Let's see. ln 6 plus 3 ln x. That's it. I can't simplify anything. I mean, I could plug in natural log of 6 on a calculator and get a decimal value, but I'm not going to do that because we just want to write it as an expression. All right. Now I have a lot going on in this next one. So I'm going to write smaller and zoom in more. Let's see, how many things are being multiplied together technically on this problem? How many different things is what I should say. 25 is being multiplied by x squared, which is being multiplied by y cubed, and also being multiplied by square root of z. So there's 4 different things, which means I should be separating them out all by addition and have 4 terms. So this would be log base 5 of 25 plus log base 5 of x squared plus log base 5 of y cubed plus log base 5 of, let's rewrite the square root of z as an exponent because everything else is an exponent. Square root is the same as writing the exponent of 1/2. Good. Is there anything that can be evaluated from this problem? The variables cannot, but log base 5 of 25 can. Also, we're not done because we need to move all of those exponents out to the front. So, what is log base 5 of 25? Let's see. 5 to what power gives me 25? 5 to the second power. And then we have 2 log base 5 of x plus 3 log base 5 of y plus 1/2 log base 5 of z. I fit it. Did you fit it? Hope so. That is expanded a lot, and we cannot expand anymore. You expand until you can expand no more. All right, moving on. We've got multiplication, exponents, and division in this problem. So we're going to use all of our logs. Let's start with what's being multiplied together. Actually, yeah. Let's start with what's being divided because I have a numerator and a denominator. So my natural log of e cubed x squared is being divided by y cubed. So the division means we change to subtraction. Then the multiplication means we change to addition. Make sure for every time you expand something, you're writing the natural log, or whatever your logarithm is for that question, for every single part. Then we're going to move these exponents. Unless we can evaluate it. This part right here can be evaluated. Remember, the natural log is base e. So this part says e to what power gives you e to the third. And we can write that on the side if you need help. E to what power gives you e to the third? 3. E to the third power. And then moving our exponents out to the front, we get 2 ln x minus 3 ln y. Completely expanded. Moving to the right. All right, before we do anything, let's rewrite the radical as an exponent because everything should be in exponential form. All right, what exponent is the cube root? So if this is 9 to the first, and then your denominator is 9x squared to the first. A cube root is a 1/3 power, just like a square root is a 1/2 power. Or you can do these separately. You do 9 to the 1/3 and x to the 2/3. That's fine as well. What I'm going to do right here is use my power to a power rule to make sure I distribute that exponent to every other exponent. So this would be 9 to the 1/3 x to the 2/3. All right. So we have multiplication now, so we're going to separate it into 2 log base 7s. What does multiplication change to? When you expand, changes to addition. And then what do you do with these exponents? Multiply them to the front. So we get 1/3 log base 7 of 9 plus 2/3 log base 7 of x. Okay, go ahead and move to the other side. All right. Examples, condense the expression. Okay, we're going the opposite direction now. So whenever we have subtraction, that should change to division. Whenever we have a number multiplied out to the front, that should change to an exponent. Whenever we have addition, it should change to multiplication. So we're condensing into one logarithm, which is much more helpful to solve these logs. We're not solving here, but it will be helpful when we're solving logs. Okay, we're going to do this in the reverse order. So we're going to start with moving the exponents back. So this would be log base 4 of 2 to the 5th minus log base 4 of 2. All right, so we can evaluate 2 to the 5th before we keep going, or you can leave it as 2 to the 5th. Either way is fine. Let's go ahead and keep rewriting, and we can change 2 to the 5th later. All right, so the subtraction means we change to division. So you will now have 1 log base of 4, and you are going to divide 2 to the 5th by 2. Now, we could write this as 32 over 2, and that's fine as well. So 2 to the 5th is 32. What is 32 divided by 2? So hopefully you said 16. You can, right here, subtract exponents as well. If you want to subtract the 5 and the 1, you can get 2 to the 4th, which is also 16. 32 divided by 2 is 16. Either way is fine. So 4 to what power gives you 16? You should get 2. 4 to the 2nd power equals 16. So now this problem has been completely condensed into just the number 2. All right, moving to the right-hand side, remember we're going to put our exponents back first. We have 2 exponents here. So natural log of 50 plus natural log of 1/5 to the 2nd power plus natural log of x cubed. All of these additions mean that you're going to multiply those values together. Let's go ahead and do 1/5 times 1/5. 1 times 1 is 1. 5 times 5 is 25. Okay, so we're multiplying all 3 of these things together. You can put them all in parentheses if you'd like. And now let's simplify. 50 times 1 over 25 gives us 50 over 25, which is 2. And then we're still multiplying by x cubed, so natural log of 2x cubed is as far as we can condense it to. Now the trouble on these is to remember which way you're going. If you're condensing, you want a small, neat answer at the end. If you're expanding, you should have something long and complicated. Okay, starting with the exponents, move the 4 to the back to the exponent position, move the 3 back. So log base 5 of 2 to the 4th minus log base 5 of x cubed. Subtraction means we're changing to division. So these are both log base 5. They will stay log base 5, but into one condensed expression, 2 to the 4th over x cubed, because subtraction means you're dividing. If we can rewrite that, we will. What does 2 to the 4th equal? 16, so 16 over x cubed. Log base 5 of 16 over x cubed. All right, moving to the right. We're going to put the 2 and the 1/2 back in the exponent positions. Log base 2 of 4 squared plus log base 2 of 9 to the 1/2 minus log base 2 of 6. Okay, let's evaluate some of these. 4 squared. 4 squared is 16. We're going to use that in a second. 9 to the 1/2. 1/2 power equals a square root. What's the square root of 9? 3. So this is log base 2 of 16 plus log base 2 of 3 minus log base 2 of 6. All right. Addition means we're going to multiply those values together. Subtraction means we're going to divide. So, left to right, follow your order of operations. Log base 2, we're going to do 16 times 3 first, and then divide everything by 6. 16 times 3 is 48. Log base 2, 48 divided by 6 is 8. Can I evaluate that? 2 to what power gives me 8? 2 to the 3rd power. Love when it condenses to just one number. All right. This is a tricky one, but it gives us a hint. Rewrite the constant as a log. All right, now, what base do we have? Log base 2. Okay. If our base is 2, then this 3 had to come from a base of 2. So log base 2 of something gives us 3. Log base 2 of something gives us 3. Log base 2 of what number gives us 3? 8. So this right here is log base 2 of 8. Because 2 to the 3rd power is 8. 2 times 2 times 2. Now we can rewrite the rest along with it. If you're ever wondering what you should put there for the answer, remember, when you simplify, that's an exponent. So you would take your base, which is your little number here, raise it to that value of an exponent. 2 to the 3rd power gives you 8. So that's how I got the 8. Also going to move that exponent back. I was tempted to write this as 3 again. Don't do that. All right, so subtraction means you're going to divide those values, and addition means you're going to multiply. So, the ones that are being subtracted should be in your denominator. All right, so we know this is log base 2. You're taking 8. You're going to divide it by x to the 1/2, and then this addition sign says multiply by y. But if you multiply by y over 1, you just get 8 times y, which is 8y. So if you want to rearrange these, you can rearrange them in the manner that best fits you, but you just have to keep the negative with the negative. So I would move this one to the end. So if I rewrote this as log base 2 of 8 plus log base 2 of y minus log base 2 of x to the 1/2, that would mean multiply the 8 and the y, which we did, and then Subtraction means to divide by whatever's left, which is x to the 1/2. All right, let's rewrite this as a radical. X to the 1/2 is the square root of x. So this is a correct answer. If you were asked to have all rational denominators, you would want to rationalize this by multiplying by the square root of x. So this would be also equal to log base 2 of xy square root x over square root of x times square root of x is x. So that's fine as well. Just follow directions on whether you need to rationalize all denominators. All right, so you should be working on Unit 9, Worksheet 5 next.